So anyway, you probably saw some of this if you were in Ilya's talk yesterday, but as far as the markets where users are coming on the internet, it is largely all China and India. There are a bunch of other emerging markets that are growing, but in the US, if you look, we've already dropped to number 3 as far as internet usage, and we already have a completely saturated market. It's 87%. Our internet growth is basically going to grow with the birth rate for the most part. Well, and with my teenagers who seem to use the internet a whole lot more than me. So if you look, India, which has been growing like crazy, is still only 30% penetration. So that's where the bulk of the market's going to be coming from in the near term. And so if you want to increase your usage, you really have sort of 2 choices. You can get more users, and as we sort of just saw, you're not getting them from the US or Europe largely. I mean, you might be able to steal them from your competition or sort of like infighting here and there. But those are going to be coming from new emerging markets, and almost all of those are mobile only. They don't have desktops, they don't have laptops, they're all coming in on cheap low-end phones. And most of these new users have really, really variable connectivity. You'll have, sometimes they'll be on fast Wi-Fi, like Google's been rolling out the Wi-Fi in train stations in India, for example. And you see like crazy usage. I think the last numbers I saw were users use 25 times as much data when they get to the train stations and get free Wi-Fi than they do on their actual cell data, just because it's actually fast and, well, it's free. Don't underestimate the power of free. And the other flip side is you can get more usage out of your existing users by having faster pages. And we pretty much see this all over the place, is anytime you increase the performance, you tend to get better engagement, more page views, more whatever your metric is. It seems people have kind of a time budget where they're spending on the internet, commercial breaks, on the commute, you know, while they're driving, whatever. And the more that they can get done in that time, they seem to consume to fill up whatever time they have available. And even within the US, we are not our customers. And unfortunately, I've got some friends that are sort of in this situation, but the yellow areas on the map, which are probably fairly hard to see, this is from the FCC broadband status report. The yellow areas are the only areas that have actually fixed line broadband. Everywhere else, it's some form of wireless. We tend to advertise that we have kind of like national broadband coverage, but that's because they include satellite as broadband. And I'm not sure if any of you have ever browsed the internet on satellite, but the round trip times, just to give you a level of where they're at, it's a 1-second round trip time to bounce off of a satellite and come back down to Earth. And that's even worse than you've ever seen anywhere on a mobile cell connection. So I don't know if I'd call that broadband. You can stream video over it, but you really would not want to be browsing the web on that. And that's not a small, tiny percent of the population. That's 10% of all of the US population has no fixed broadband, and it's mostly rural areas, as you'd expect, because it's really expensive in the middle of farm country to run fiber optics. And so as I mentioned, the non-fixed broadband, it's mostly satellite and cellular. And all of these have data caps as well and huge latencies. So even on the non-satellite case, cellular, in a good case, you're talking 100 millisecond round trip times. It can be way, way worse than that. We've seen unencumbered 300 millisecond round trip times. When you start actually shoving a whole bunch of data, we can see the round trip times get as high as 1.3, 1.8 seconds on a cellular connection. And as Max was kind enough to point out, and Ilya also had on his slide yesterday, even when you're on an LTE connection, with the data caps, everyone's got unlimited data these days. Well, everyone advertises unlimited data these days. What they don't really sort of tell you is once you reach a certain threshold, they really throttle you back down. And in the case of T-Mobile here, it goes down to 64 kilobits, which is 6 kilobytes per second. You can think about how long it takes to download even like 100K of JavaScript, much less a 2.5 megabyte page. You're measuring minutes. And so I sort of want to take you down the journey of what it means to develop for one of these experiences. And on the site development side, I'm kind of sort of used to working off of mocks. I'd work with a design team, they'd give me what the page and product needs to look like. Here are sort of the features, go build this. And I was like, okay, awesome, here, I'll go ahead and build it, and then our discussion's done. I want to make sure it's pixel perfect and everything clicks and works as they designed, and that's about it. But in reality, the experience ends up being more like this for users. And yes, I'm going to make you sit here and watch the whole thing.
Make it stop.
And this isn't a spa for anything. This is loading on a 2G connection. So it's a reasonably slow connection, but it's actually a really fast site. And I was trying not to punish you guys too much, but 25 seconds, give or take, to load. It felt like an eternity. When I'm doing a lot of testing in emerging markets, and we actually can test on like actual cell networks in these countries, as well as networks that look like the cell networks, we see load times on the order of 3 minutes of blank time before you start to see anything. I couldn't imagine putting one of these videos up here. The audience would probably be half gone. And so I want to make sure that when you're talking about the experience with your design team and your product team, you're actually talking about it as a full experience. It's not a static image. That's not what your users get. They stare at a blank screen for a certain period of time. How long can that be? What's acceptable? What's not? Can the content move as it loads? And just a quick hint, the answer to that is no. You want all your content to stay where it is. You're going to start seeing more and more penalties and sticks around that, but we like carrots, right? So I think for mobile friendly, you're going to start seeing that it needs to make sure that your content doesn't relay out and you kind of have a static fixed result. When should the text display? When we were loading it, it was probably 16 seconds in. You kind of got the background and you got some colors, but you didn't actually get any text for the content for another few seconds after that. Is that acceptable? Should you be using a fallback font in these cases? Do you want the text to show before the images? How should the images come in? Should there be progress indicators of some kind? These are all the kinds of discussions you need to be having with your design team, and treat it almost more like a movie or an experience than a static, this is what the page looks like. So on the search side of things at Google, in a couple of countries at this point, we've gone to the point where we've got a really rich search, which, you know, you wouldn't think there's a whole lot involved with the single text entry field, but I think it's probably grown to be somewhere like on the order of a megabyte, give or take, for the actual search page, because of all of the rich, you know, you type, you interact, it moves the search bar, doodles, God knows whatever else is going on at the time. So for a lot of emerging markets, we actually have a new search lite experience, which is kind of like search was 10 years ago, without all of the rich JavaScript and everything else. It's a single request, no JavaScript, all of the HTML comes down. It's something like on the order of 100K, everything's inlined, and it's a super fast experience for cases where we think you're on a degraded connection, so you can actually get search and you can still have a decent experience on slow, low devices. We've also started deploying, we sort of call it a search intervention, but Web Lite is a case where the search results page, if we see you're on a light connection or a low-end connection really slow, we will transcode the pages that you're going to be going to, like a news page or whatever. Google will look at it, extract what it thinks is the important content, rewrite it, and publish its own version of it so that we can deliver a fast experience for these low-end connections and they can actually see something. As a site developer, you'd actually have to opt out of this in the few markets it's launched in. I believe it's Indonesia is the main market it's launched in right now. But it results, when it's enabled, 4 times faster page loads, 80% less data. And for the sites that are actually seeing the content, they're actually getting 50% more page views because people are actually being able to see and consume the content. But so these are things that Google's doing on their side to try and take the existing web, as sort of slow and bloated as it's grown over time, and try and cram it into these emerging markets in a way that they can still consume content. And so I kind of postulate to you, how fast is your site? When you're talking to your product team or your developers, you can ask them, okay, so how fast do you think our site is? These are the Google, I lied, I'm going to talk about web page tests a little bit. These are the Google Analytics for web page tests. It's sort of, on average, it claims it loads at around 3 seconds, and this is the full page load time, not the best metric, but it's kind of like the worst case. It takes 3 seconds to load on average. The histogram, the distribution, you can see, well, that's sort of the case, but I still have about 10% of the users where it takes more than 7 seconds. And on the scary extreme end of the case, I've got maybe 1% where it's taking 20 plus seconds to load. And even if I'm just looking at the server response times, 400 milliseconds, yeah, that's not bad. And the vast majority of responses under a second. But I still have, 5% of the requests where it's taking over a second before the user even gets the base HTML back. And so when you're talking to the dev teams, you're talking to the product teams, and they go, okay, we've met our goals. We have a 5-second page load time. I challenge you to go back to them and go, okay, are you willing to put money on that? And say, okay, anything that takes over 5 seconds, we're going to start dropping the ads, right? We load in 5 seconds. There's nothing to lose here, right? So for your users that are having a slow experience, or where you think they may be having a slow experience, it's time to rethink, do you really need to be delivering all of the content that you're delivering in the full rich experience? And you can do this sort of at the runtime. I'm going to be talking about a few different techniques that we can do at runtime to hopefully be able to do this reliably and consistently. And so some of the things you might want to consider is, if you have 3 ad units on the page, maybe start dropping those down and only have 1, like the one you really care about. And even that, maybe not. Maybe you just want the users to be able to consume the content. If you have the option between rich media ad tags and falling back to text ad tags, fall back to the non-rich media cases when you've got slow connections, so you can still at least monetize them a little, but not like completely punish their connection. Maybe it's a good time to decide not to inject your tag managers or not to be doing A/B testing. Those tend to really, really be bad on the slow connections. Lazy image loading, I'd kind of encourage you to do all of the time anyway for stuff that's not in the viewport. But in the case where you're doing lazy image loading, one of the things on a fast connection you probably want to do is, after the page is loaded and all of the visible images have loaded, you probably want to start pre-filling a bunch of the lazy images so that when they start scrolling, they're already there. In the case of a really slow connection, you probably want to skip that last step, or maybe be more intelligent and only pre-fill 1 lazy loaded image or something like that. And sort of the last one is, it's a little more complicated because it's not so much about the content, but it's how it's served. And one of the things you have to be aware of is, when you're on a really bandwidth constrained connection and you're talking to a whole lot of different domains, or even you have 6 connections open to a single domain, TCP does not behave well. And you can end up with something where you have like a 200 kilobit connection where half of the data, half of the bandwidth is wasted on retransmits. Because you have so much data that's coming down the pipe, it's overfilling the pipe, and you end up squeezing that 200 kilobit down to an effective 100 kilobit. And HTTP2 gives us a really good way to solve that, where if you're running over a single TCP connection, it can better deal with the congestion and not overfill the pipe. But it also means you have to not be calling out to all of these third parties. You have to not be doing, if you're doing domain sharding, you need to be sure that they're all sort of coalescing back onto a single connection. And that's one of the benefits that you get when you're using sort of a proxy browser like the Opera Mini or UC Mini or Chrome's Datasaver, where it's talking to a single proxy server. It channels all of the data over a single connection. So even beyond compressing the size of the content down, they get a lot of benefit just from having that single data connection, where if you're talking to 200 different third parties and fetching from CDNs, you're challenging an already challenged connection. So as far as making the decisions, you have a lot of flexibility and a lot of tools at hand. And so in your JavaScript, right at the top of the head, you can look at performance.now, and you can see how long has it been since navigation started. Has it been more than 5 seconds? Hey, we only load in 5 seconds. I'm going to turn everything else off and just give them the content, right? That's your SLA. All of a sudden, are you having an SLA with the business and saying, okay, we said we're going to always load in 5 seconds. If not, we're going to degrade into a super light experience. You can also look sort of almost at any point in time. You can look at the navigation timing information. One of the ones that I like to use a lot is the socket connect time. Well, in this case, it's response start versus navigation start, but you can even look at like socket connect end versus socket connect start and use that as a proxy for the round trip time. And you can see sort of what is the expected round trip time of this client to get a feel for what the connection speed looks like in practice. At the end of the head, you can sort of make the same decision and go, you know what, all of the JavaScript libraries I loaded, now it's taken me 20 seconds to load all of the libraries I need to enable the functionality on my code, and make another tiered decision on what you want to cut out. And same thing sort of as you go down the page, as you're about to inject an add tag, like down at the footer of the page, you've done a whole bunch of work. Where are you in your SLA at this point? Unfortunately, sort of my sad frowny face at the end is a lot of these, if you're making runtime decisions, you're going to be defeating what the preload scanner does. So just be kind of careful and thoughtful about when you're doing it. If you're using JavaScript to inject an add tag, you're already sort of out of bounds of the preload scanner anyway, and so that's a good thing to decide on and what kind of add tag to load. And so a few other things that you can do outside of just pure timing based, you can tell, hey, with the navigator connection info, you can say, does it look like I'm on a 2G or a slow 3G connection? And just get it from the browser and have the browser tell you, yes, I think I'm on this kind of connection. Don't bet on it, because like we saw earlier, even on an LTE connection, you can have like insanely slow bandwidth. So the timings are a really good safe bet. If it tells you you're on a 2G connection, you can be sure you're not going to be having a fast experience. It's just you can't assume that if it doesn't tell you you're on a slow connection that you will have a fast experience. Ilya also mentioned yesterday, if you're on a battery and you end up with a low battery situation, things can get really slow as well. So maybe you want to take a look and make some decisions about the battery and not serve rich media ads or autoplay video when they get down to like 15% battery levels and things like that. In service workers, sort of all of the new hotness, you can apply various other SLAs as well. You can do it on a request by request basis and go, hey, these are the third-party requests, these are the add tags, the tag managers, whatever. You can do timings based on when the page load started and decide to block down in the service worker level. And you can even sort of do the dynamic heavy versus light fetching decisions all the way down at the service worker level and just rewrite the requests as they're going through. So you don't have to like rewrite all of your content pages. You can do the logic down in a single shared module for your whole site that then makes the runtime SLA decisions. The one thing you sort of want to be careful of is you kind of want to deliver a consistent experience to your users and not flash between this like really heavy, rich, slow ad experience and all of a sudden, ooh, it was fast once and then now it's slow. So to some extent, you want to be able to track the behavior over time and either through cookies or local storage or IndexedDB, remember and try and have it be semi-sticky. So you're not flipping back and forth on a per page load basis where you probably fall back quickly and slowly make the decision where it looks like we're having regularly really fast experiences. Okay, maybe I'll try once again on a rich experience before falling back again. On the server side, so we talked a little bit about things that you can do on the front end in the front end code. You can also make decisions on the server side. There's the Datasaver in Chrome. When it's enabled, it also adds a save data header to the HTTP requests. And so on the server side, you can go, hey, they've enabled Datasaver mode. They really want a light experience. Opt in directly and give them the light experience. And this is enabled in Chrome, Opera, and Yandex browsers. Pretty much all of the Blink-based browsers at this point. If you want to do that, or you basically don't want any of our Datasaver proxies or even the search transcoding to be mucking with your pages, if you add a cache control no transform header on your HTTP responses, you can say, basically, I've delivered the experience that is appropriate for the users. I'm taking the responsibility for delivering a light experience. Don't do anything to my requests. And at least the Google stuff will honor that. The Datasaver proxy won't recompress your JPEGs or your images. The Searchlight won't transcode your pages. It will serve your pages directly. For me, this is where things get a little more interesting. You can get RTT estimates. And so, like on the Searchlight, one of the triggers we use to decide that you're probably going to need a light version of the search page is to look at the estimated round trip time of the connection as soon as you hit the search backends. And if it's over, say, 100 or 200 milliseconds, we're assuming that you're in a situation where you've got high latency. High latency tends to be fairly well correlated with slow experiences. As we sort of talked about in satellite, you can have high bandwidth and high latency, but for the most part, if you've got high latency, you're going to be in a situation where you probably want to be delivering light pages. And so at a connection, at a TCP level in Linux at least, there's a socket option to get round trip time out of TCP info. And the really exciting bit for me is Nginx exposes this as a variable, so your web servers can just have a variable that goes, hey, this is the current RTT time. Application server can make a runtime decision based on that, what kind of content you want to serve. Same goes for Apache Traffic Server. And also add all of this to your access logs so you can start logging what the client round trip times are for people visiting your site. And so, more difficult, but still also something possible. You can also track IP blocks coming in, probably less effective with IPv6, or maybe you just assume if they're coming in IPv6, they're coming in mobile, and always give them a light experience. But you can track IP blocks and assignments and see if certain blocks tend to always have certain types of experiences and start doing IP-based mappings. One thing you have to be really careful of, and this is sort of on your, is our light experience working analytics? And when you're trying to figure out, when you deliver a faster experience, what's that doing? Or what do your metrics look like when that happens? So YouTube had a good blog post probably a few years ago at this point, when they launched YouTube Feather, which is a super lightweight video version of their video player for emerging markets where you can stream low bandwidth conditions. When they launched it, it was like, okay, we've got this super light experience, our metrics are going to improve, it's going to be awesome. And all of a sudden, when it launched, their time to first stream, which is the main metric they look at, got a whole lot slower. And they're like, oh shit, what did we screw up? And everyone's scrambling and going back. And the problem is, it ended up starting to spread by word of mouth that people were realizing they could now stream video in situations where they couldn't before. So now all of a sudden they have a whole country coming on board effectively with really low-end connections that are starting to stream video and completely skewing all of the metrics. And you'd think we'd learn and we wouldn't repeat the problems and have the same problems again. But so in Chrome, this was my nightmare for the last year or so. We were playing with the order and priorities for resources and how things should get fetched. And we were doing things that we were targeting, particularly for emerging markets where maybe sites didn't optimize so well, and we'll try to get as much above the fold content loaded as quickly as possible, regardless of how the site constructed their HTML. And in lab tests, we were seeing 5–10% improvements, and we were all excited, and we launched it, and the lines went nowhere. And we were like, oh, we must have screwed something up. Let's start carving it up by country or by region. The lines still went nowhere. It's like, damn it. And after much pain, we finally tracked it down to and this was all doing an A/B test, so we had both going on at the same time. We were getting something like 1% more users or more activity on the case where we had the faster behaviors, but they were all in the long tail. And so all of our metrics were being skewed because the long tail actually got a little longer and we were getting more users on the slow connections. And the end result was our top line metrics, our trended metrics, ended up not going anywhere. So in general, as you're doing any of the performance work, just be aware you can make things a lot faster, and your trended charts may go in the completely opposite direction or not move at all. So you almost have to isolate population pools to be able to see what's going on with your performance. And so we've got a fair number of carrots trying to encourage sites to go faster and faster performance on all of this kind of things. There are some sticks as well. And so Bruce talked yesterday about Opera's ad blocking. If you haven't already seen, you're gonna be seeing a lot more talk about user agent interventions. And that's where on the browser side of things, we're starting to take a look at, okay, specs be damned. If we want the users to actually have an internet they can consume and a user experience they can consume, what runtime decisions do we need to make to deliver them that content, regardless of what you as site developers or whoever in here is a site developer have told the browsers you want. And so a simple case of that is Datasaver mode, where we'll completely recompress all of your images and deliver them in a lighter form. There's a more aggressive version of that where instead of images, we deliver color blocks in super constrained connections, and then users can click on an image if they actually wanted to see the image or load all of the images. The mini proxy browsers are sort of a case of that, where they'll render in the cloud and then send the content down. The JavaScript may or may not work. Ad blocking is certainly a case of that. But we are also becoming a lot more aggressive on a feature-by-feature basis. And so that's a really long URL. The slides will be available if you actually want to go see it. But there's some discussions in the Blink dev, I think there's an intervention dev. So we have an entire list on the Chromium group for talking about the interventions that we're looking at. It's basically anyone proposes, hey, I think if we do this, we might be able to get more content visible in emerging markets or deliver content faster. But some of the things that are certainly going on there, active scroll listeners, where you attach an on-scroll event, they're sort of notorious for jank. Ads and true view ads in particular, where they want to see what's visible in the viewport. If they haven't moved to intersection observer yet, just completely disabling those for cases where we think we're going to be introducing jank, if it hasn't already rolled out, is certainly on the table. So there will be no more active scroll listeners in those cases. Blocking document.write, don't know if that'll actually ever make it out. We have experimented with it, we've implemented it, we've done small trials with it, we've certainly tested it in the lab. It's not like explicitly an ad blocker, but it has the side benefit of blocking tag managers, A/B testing, and large chunks of ads. But this is sort of going after the behavior where on really slow connections, just disabling document.write doubled the speed of loading pages for the most part. And when you're talking about 2 or 3 minute page loads and huge amounts of data, this can be a fairly big deal. Either background or even just iframes in general, if it hasn't happened, it is definitely happening. We're talking about throttling, slowing down timers, request animation frames, all sorts of other things, lowering the priority of resources in frames, largely because for cases where frames aren't the main content on the page, they're the ads. Yes, you want to get paid, you want ads, but they're interfering with loading of the main content. And not all of these kick in all of the time, right? So right now, a lot of these are sort of being triggered based on detecting conditions where we think things are so extreme we actually need to do these interventions to get the content to the users. Immediately falling back to system fonts, ignoring whatever you asked for web fonts. That shipped in Chrome 49. So on slow connections, particularly in emerging markets, you'll end up seeing this. If you have custom web fonts, regardless of what you're doing about fallbacks and everything else, if it's not in cache, we will fall immediately back to the system web font just to show the user some content. We're talking about automatically lazy loading images. So if it doesn't show up in the viewport at all, we're not going to load it, or maybe we'll do a range request for the first few bytes so you can still get your tracking beacons and retargeting and whatever else. But until users scroll it into the viewport, maybe we won't load your images. Although I still encourage you to actively do your own lazy loading images, because don't rely on us doing it, because you will do a much better job than we do when we're doing it sort of globally. They're also talking about, and this is more about cases where it's generally things behaving badly. I'm not sure if you ever navigated somewhere, clicked on something, and the back button never works because they keep rewriting the history. So we're talking about cleaning up the navigation history so that only based on actual actions from the user do things get put into the history so that the back button will always work, for example. And so, like I said, these are the things that are currently in discussions that I'm aware of. It's a wide open field at this point where pretty much anyone in the Chrome team can just sort of recommend, hey, you know, I was seeing this kind of behavior, and I think if we do X and block this from happening, we can actually deliver more content to the emerging markets. It's going to be something you see more of, but I do sort of, we're in this situation a lot of, because just like with sort of the ad blocking situation, things have gotten so bad that emerging markets can't consume content, and we actually need to do something about it. And if we start delivering better, lighter content by default, we won't have this problem, right? And so that's it as far as the talk. I did want to, if you can provide feedback, always appreciated. Lets me know sort of what works, what doesn't. Thank you. And we have a little bit of time for a few questions. Here.
So you talked about automatically throttling back timeframes, et cetera, when you detect poor conditions. Is there a way to force that on in the lab, say in web page test, through a flag so we can look at the effect on our pages?
So the question was about throttling iframes. Is there a way to force it on? Yes, so most of this stuff, the problem is there's a way to turn it on, but it's not like it's going to be documented very well. So in web page test, you can pass custom command line flags to Chrome, and just about everything that I've talked about is launched as an experiment, and there's a way to turn on Finch experiments in the Chrome command line flags. If you ping me offline, I can pass an example for like the resource priorities experiment, but unfortunately, to know for any one of the specific interventions what the flags are to turn it on, you kind of have to look at the actual Chrome code or be on one of the lists. If you tweet at me, I can probably also find the flags for any particular experiment that's going on at a time if you're interested in it. Over here.
So one of the common site speed performance concerns that we've heard with Android Chrome browsers is that they are slower than Chrome or Safari or some of the other browsers on iOS. Now, is this a valid issue? And is something being done to address it? If so?
So the question was, we've heard Chrome on Android is slower than Chrome or Safari on iOS. To be fair, Chrome on iOS is Safari, so effectively it's Chrome on Android is slower than Safari on iOS. Is this valid or not? Honestly, I don't know for sure. I think a lot of it depends on the hardware and the environment it's running in. Certainly, Safari on the iOS devices is a lot faster than Chrome on a lot of the devices in emerging markets. On like a Nexus 6 versus an iPhone 6, I don't think you're going to see a lot of difference. The problem is in the emerging markets where you have, Ilya had a really good slide yesterday, $33 Android phone that has 256 megs of RAM, a single dual core processor, and can barely run the browser. That's sort of the situation we're in a lot of these countries, just because the GDP and the income levels are so low that buying a high-end phone isn't where the market growth is coming from. So a lot of it's going to depend on where you're looking in your analytics. If you carve it down to a specific device type, you may not see the same differences. But if you're looking at the entire pool of all Android devices, yeah, I can just about guarantee there's a whole lot more low-end Android devices than there are low-end iPhones. Any other questions? Steve?
Can about how web developers can measure connection speeds or other things and then alter their page. And 95% of websites aren't going to do that because that's a lot of work. So the automated throttling or interventions that browsers might do are great because you don't have to do any work to have that happen. But can you talk a little bit more, maybe I missed it, about how what are browsers measuring to make decisions like, I'm going to ignore iframes or ignore image requests outside the viewport?
So Steve asked a lot of questions in there, but basically talked about how site developers can make decisions at runtime to reduce content levels, but pessimistically not going to do that. What does the browser use to make its decisions to do various throttlings? To some extent, it uses historical navigation data. Last page load took X amount of time. It has a little more visibility into the connection quality that's currently going on than it exposes up to the browser, right? So it does know the RTT time when talking to various servers. It does know how long it took to download chunks of HTML, for example. It can start to learn that after a certain amount of time, it has taken like 10 seconds to download 100K, right? So there are a lot of signals that we have inside of the browser that aren't necessarily exposed up to JavaScript. Right now, most of the network style decisions about blocking document.write and things like that are being done based on network connectivity information. Throttling the renderer can be based on CPU consumption and how slow things are going at that level, for example. As far as scrolling, can be done certainly based on maybe the first time it misses a 60-second frame budget. It can just go ahead and disable all of the on-scroll handlers. And a lot of it, the decision's going to be made as close as possible to the thing that's being interfered with to make sure that we're actually targeting a behavior and not sort of arbitrarily blocking things just to block them. We're blocking this because it's interfering with the behavior that we're trying to deliver. Oh, I think one more question and then we'll call it.
You mentioned that Google does in-network testing in countries. I was curious, how do you determine what those countries are and how widespread that is?
So you mentioned that Google does in-country carrier testing, and how do we decide which countries and how distributed that is? So a lot of groups do a lot of different testing. We've got people in country that work there, for example. We also send teams to the various countries. But as far as actual testing, we've deployed some web page test agents on actual carrier networks. In countries where we have offices, for example, we'll have the office just sort of babysit the phones or whatever. We've targeted, you can probably just go back to my first slide and see where is all the new emerging market growth going to come from, and just assume that we've targeted the countries where a lot of growth is going to be coming from, minus China. India, Indonesia tend to get a whole lot of focus. Brazil also gets a lot of focus. India certainly gets the vast majority of the focus just because the growth there is going so quickly and there's still such a huge untapped market. All right, so thank you very much. Definitely hang around. Ben's right after me.